Welcome back to the Cycle World podcast. I'm Mark Hoyer. I'm the editor-in-chief, and I'm with Kevin Cameron, our technical editor. We've done more than 30 episodes. Thanks for riding with us. This episode is brought to you by Octane Lending. It's our parent company. We'll put a link in the description, octane.co. You can use Octane to buy a motorcycle, get your financing, and see what your ability to buy looks like. Give you a no impact credit check. You can get in there and see what you want to buy. So this program would not be happening without the support of Octane. So thank you.
Yes.
And this week's episode is the Harley-Davidson XR-750, legendary dirt track bike. Amazingly beautiful motorcycle. I like dirt track bikes because of how simple they are.
Exactly.
And how elegant they are. I like dirt track racing because it's on dirt. And it's, what is it? It's like the universal. It's the constant. Dirt is the constant. Even though dirt is highly variable, traction on dirt sort of never exceeds something.
Yep.
Like no matter what you do to the tires, no matter what you do to the bike, there's only a certain amount of traction available. And yep. I think that's how dirt track is such an elegant sport. I mean, violent and amazing, but also elegant. What Willie G told me at the Del Mar Mile in 2000, mile racing is it's the best racing in the world. And I think I love the mile because it's so fast and the draft and all that stuff. It is really cool, but it was neat to be there. Let's talk about the XR-750, Kevin.
Well, the first time I saw one, I was struck by the fact that the front and rear wheels were as physically close to the engine as they could be. If the front fork were moved back a quarter of an inch, the front wheel would move up and hit something on the engine at full bump. And in the rear, there was hardly any distance between the swing arm pivot shaft and the front of the rear tire. So very packed together to get the shortest possible wheelbase, which of course we know translates to rapid turning. And as you said, it was a simple motorcycle because to the highest degree, it represented two wheels, an engine, and a place to sit. So it's hard to get any simpler than that without doing away with one of the cylinders, but that's another story altogether. I think everyone started out with V-twins around 1910 because it was the easiest way to get more power when the singles that you were already building had been maxed out. So you just change your crankcase casting cores a little bit to provide a second cylinder pad as close to the first one as was convenient. For Indian, that was 42 degrees. For Harley, 45. And you just stuck a second cylinder on there. And the engine still had a single crank pin. And the connecting rods were fork and blade where they went onto the crank pin. So one connecting rod was the fork and the blade fitted between. And there were roller races between the rods and the crank pin. So that's the origin of the V-twin, the simplest way to build a more powerful bike, a more powerful engine than a single.
You know what I appreciate about doing these talks with you, doing the show with you, Kevin, is that we can always go back to the Big Bang. It doesn't matter. It's like we talk about metals and it's like the molecules that, it's really cool. But it's nice.
I think though that Harley riders like to feel that they're part of a great tradition, and it does go way back. That's just what Glenn Curtis did when he could see that his singles weren't going to win the races that he was running, so he added a second cylinder. And when the carburation for the second cylinder was rich, he drilled a hole in its intake manifold to lean it out. It just sucked in air. And these were very rough and ready developments. You want more power? More cylinders. And Jim Fueling wasn't the first person to build a W, but it's the obvious next step beyond the V-twin.
Yeah, Jim Fueling, legendary guy, developer. He did work for GM, made GMs make a lot of power, and did a lot of work for Harley-Davidson and exhaust port design, which was one of the things that he sort of built his tank collection on, doing exhaust port optimization, making the exhaust port as small as possible to get the flow so that the heat didn't go into the cylinder head. And he helped Harley with that on various points in development. And what Kevin's talking about is a Fueling W3, which was adding a third cylinder to a Harley-Davidson. And I road tested one of those years ago, rode it all around, and was hammering it. His shop was in Ventura. I was riding back roads, and they're like, yeah, take off, do whatever you want. So I just rode around and was hammering the daylights out of it. And then I smelled oil, and I pulled over, and there was oil coming out the breather. And I'd been riding it very hard because that's what I'm supposed to do. I'm supposed to find problems. And if you just rattle around and ride to the grocery store, you don't find problems. And so I called him on the phone, and I called not Jim, but I called Jim's guy who kind of set me loose. And I'm like, hey, man, we're getting a little bit of oil out of here. There's some oil on the back tire. The breather's, going. And he's like, oh, good. It means you're hammering it. So he was fine with it. I think, sidebar, I think during development, especially on big twins, that breather control seems always to be a problem at some point, and it takes a little bit to figure it out.
No question about that, because you have two big pistons that are moving almost together. And so the volume under the pistons is quite large at top center, and it gets a lot smaller at bottom center. And that rushing of air goes up and down the pushrod tubes, and it can cause oil to accumulate in places you would never dream of it's getting to.
Yeah, I think that's a possible show. I mean,
no question about it, because
oil controlling the cylinders.
They want what they need most of all to prevent in these engines that have their flywheel inside the crankcase is called wet sumping. When the oil scavenge system that is picking up the oil from the bottom of the engine and returning it to the oil tank cannot keep up with the accumulation, and then the crankshaft whips that oil around in the tight-fitting crankcase, and this becomes a high-speed viscosity measuring apparatus. And by golly, that viscosity turns into heat in a big hurry. As Dick O'Brien, long Harley's racing manager, said on one occasion, he said, you could see it on the straightaway at Daytona. When it would start wet sumping, it was like a giant invisible hand came down and just said, no, you don't. And the bike just...
Oh, and so much heat, right?
Yeah. Pushes your oil temperature out of sight, because, of course, all that engine power is going straight into the oil at the rate of 746 watts per horsepower. So, I made a little experiment yesterday. I stood over our kitchen toaster with my face about 18 inches above the slots, and 746 watts came up into my face, 1 horsepower, and I thought, this is a graphic demonstration of what happens to front tires in MotoGP. Because there, the heat rejection is more than 300 horsepower. That's 300 kitchen toasters all blowing on your motorcycle if you're drafting somebody. So, but that's neither here nor there. Where's the XR-750?
Yeah, I know. That's what I love talking to you, Kevin. I mean, I think it's why we do the show, because we could sit down and we could write a really beautifully, highly focused story about the XR-750, but then we don't get toaster talk with Kevin Cameron. So, and that's why I'm here.
Well, there's a great little handbook that was written by Pete Zylstra, who was the draftsman, the detail draftsman on the aluminum XR. And Harley built their first OHV race engine, 750 race engine, for 1970 as a result of push and shove in the competition, AMA's competition committee. And they decided, effective 1970, everybody would get 750 cc's. So for whatever reason, Harley-Davidson made a 750 out of a Sportster engine with a lot of changes in a lot of details. And the original Sportster of 1957 had iron cylinder heads and iron cylinders. Now, aluminum, which we take for granted as the normal material to make cylinders and heads out of, conducts heat 4 1/2 times faster than cast iron. That's a bunch. So I'm not sure how they came to make that 1970 engine. Either they were between a rock and a hard place in getting 200 bikes for the beginning of the AMA season, or they thought, well, it'll work on dirt track. We can't expect to win Daytona with it. I don't know what they knew when the season started. But Dick O'Brien told me at one point, he said, if you finished a dyno run with the 1970 iron motor, and you happened to be on your way out, you turned off the lights in the test cell, you could see the heads glowing dull red. Now, if you want to know a condition of an engine that encourages detonation, it is glowing red hot. You suck fresh fuel air mixture into the cylinder and place, mind you, the outside of the cylinder is glowing dull red. What's the inside doing? It's really in bad shape.
Yep.
So they got to Daytona that year, and they had to lower the compression ratio right down until it was as low as it was on the KR, which by that time had been developed to 58 horsepower, and it had basically just killed the Triumph 500s.
A 750,
Buddy Elmore,
750 flathead. That's the KR.
Buddy Elmore had won the 200 in 1966 on a 500 Triumph that was nearing its development limit, and Gary Nixon won it in 67, and it was looking like this is Triumph Speedway here. And Harley came up with a bunch of really inspired modifications that were the result of men who had a lot of experience but didn't work for Harley-Davidson. At any rate, they built these iron motors, and they built 200 bikes. And the story of the development from that point onward is continuous change. Oh, this is breaking. Well, we can make a larger radius here. It will be less sensitive. Okay, that's solved. What's breaking now? Oh, no, there are 3 things that are breaking now. Oh, we're having trouble with the connecting rod bearing. We're having trouble with the piston rings. And this was nothing strange to the aircraft engine industry, which had been building those horribly complicated radial air-cooled engines in the 1930s through the mid-50s. Every year they came up with more power, and Gremlins came up with more failures. So it was a constant process of fighting the power upward and trying to follow the power with reliability. And it makes fascinating reading for somebody who's done any of this kind of work. I looked at a photograph of the bearing cages that they began to make for their XR engine, and they look just like the bearing cages that I made for my 750 in 1972.
No, that's satisfying.
They did it a little differently, and I thought, oh, that's clever. If I had my life to live over again, that's how I'd do it. But a lot of talented people working on this thing, and not all of them working for Harley-Davidson. Dealers had their own dynos. These were days when well-equipped dealers had their own racing programs. They had their own riders. There was such enthusiasm for motorcycles through the 1970s. That was the golden age when the numbers were huge.
Well, I wish this is what is this? Hey, Moto America. Bagger racing is awesome. We need double the bikes on the grid, and you need to make it affordable for a dealer. You need the big dealerships to be able to do exactly what Kevin said was happening in dirt track. And the other thing is, bagger racing is probably the worst thing that happened to dirt track in the last 20 years.
Yeah.
Just because of the focus. It's popular, it's great. It's really something.
But it's sucking up resources.
Yeah.
Yep. Well, we can wish for things, but only happenstance provides. But I think that the XR-750, of course, in 45 years on dirt track, they won the championship so many times. The real exception was the 5 or 6 times that the Honda RS-750 with Honda's riders managed to take the championship. And everyone became so upset about this. Oh, well, this calls for action or something, doesn't it? Well, no, it's called competition, I think. It's not the obligation of the fast guys to slow down. It's the obligation of the slow guys to speed up.
Yeah, well, it's a good story because in the day I was talking to my old boss who was pretty close with Bubba Schobert, and he said Bubba, at the time when Bubba was winning, they told him don't win by too much. So when you're going, he's on an RS-750. Bubba Schobert's riding an RS-750, and he's going down the straight. When he's pinned, he's not pinned. He's holding just enough to stay just ahead so that he doesn't get restricted. It's like don't win by too much. Keep it in your pocket. Don't let anybody know what we got.
So they decided that they were going to have the late Jerry Branch, who had a dyno, and was famous for being willing to use it. He would run a series of tests with these engines and with various forms of restrictor to come up with a way of equalizing performance. And I got chosen to go out and sit there just behind Jerry Branch and watch this whole thing unfold. And one of the things that he had that was just wonderful was he had a very light suction blower, and he would hook it up to the carburetor float bowl vents. And he could pull the float bowl vents down 1/4 of an inch of water in pressure and see the effect on power. That is, he didn't have to run in and out of the dyno room changing jets. He could just say, let's lean it down a little bit and see if we pick something up. Oh, no, let's go the other way. Here, this looks good right here. And it saved a lot of time. And I saw it work. And I also saw the Harley's torque curve. The engine would start to accept full throttle without popping and banging from about 55 to 5,800. And it would rev on until the Dick O'Brien nervous point of 9,200 RPM. He didn't like to see all these privateers pushing the revs because he had seen all the stages in all of the parts in the engine that had been necessary at each step. Another 50 RPM. Oh, well, now you're going to have your garden will come up with weeds called problems, and you'll have to pick those weeds out. But the privateers, of course, the dictum in racing is if you don't win, if you don't do well, the people who are helping you will become interested in female mud wrestling or some other activity. So he tried to, guys, please. But they kept going down. They started out with rollers, big end rollers, the big end of the connecting rod, that were 8 millimeters in diameter. Then they went to 6 millimeters, and then they went to 5. And the reason for this is that as the bearing on the big end goes round to perform the engine cycle, the connecting rod is swinging from side to side. And so the connecting rod is adding and subtracting about 25% to the speed of the crankpin bearing. And the crankpin bearing has only the contact of the rollers and the crankpin and rod to keep it following that speed change. When the rollers are too big and too heavy, and the cage holding them parallel to one another is too big and too heavy, it can't follow anymore, and the rollers begin to skid. They scrape oil off of the friction, the rolling surfaces, and things go from bad to worse. So they had many steps to follow the motion. As the engine revved up, they had to make the rollers in the crankpin bearing smaller and lighter. And it was eventually the death of the XR-750, not because it wasn't fast, but because it began to be unreliable in ways that were hard to fix.
Yeah.
Chris Carr,
Yep.
I spoke with Chris Carr in one of those infield parking lots at in Annapolis, and he said, well, when I was a factory rider, they were giving me a new bottom end every weekend. And that meant having cranks ready to go in the engine that had already been rebuilt and trued, and just carrying that stuff with them. And that's not unusual in very energetic, fast developing racing. When the Italians began to get past 12,000 with their little 125 singles in the late 1940s, they were changing cranks every race meeting as well. And there were a lot of Japanese Grand Prix bikes where they were using one crank for practice and another crank for the race. So Harley and their XR had got into that rough territory. And the decision then would be, what if we put a plain bearing in this thing?
Well, that's what I would wish for.
Yeah.
I was at Santa Rosa when the FTR 750, Joe Kopp was racing that around it. And it's kind of like, big debut. And it was a pretty messy track, hard visibility and stuff. Joe, shout out to Joe because he's close to my age and he was hauling ass. He was riding so fast. But Brad Baker was there and he was running an XR-750 and his times were great. And he was able to ride the cushion. It was unbelievable. He was like riding high, just clipping the hay bales on an XR-750. What do you say? The emblematic image of that situation was during one of the practices, one of the heats or something, Brad Baker's bike broke. I was sitting with Terry Vance and he's like, if we just develop this, if we could do something to make it reliable, it's fast enough.
Yeah.
We could just make it reliable. Well, then, Brad's on a broken bike and Joe, I think it was Joe, it was an FTR 750. It had to be Joe, but pushed him back to the pits. Yeah. Pushed Baker back to the pits. And that was like, to me, that was the image of what was happening is like, well,
Sure.
we're not developing this, but man, an XR, it's a 45. That's what's good about it. It's got that 45 and they can put it right up on the front wheel. They can move the engine around to put it where they want in the chassis because it's a 45. It's not a 60. It's not a 90. It's really neat. And then the flywheel mass and all that stuff. I mean, the FTR might deserve its own program with its liquid cooling. Its torque curve is a thing of beauty. It has the variable mass flywheel, although I don't think they're allowed to vary the mass.
They're not anymore, no.
But man, imagine an updated XR take taking all that. You don't need, gosh, do you need to even change the chambers? I guess you would. You might make it 4-valve, but do you need to? I don't know.
Yeah. Well, they went through a fabulous amount of work on the valve train, and I had no inkling of this, but it was described in terms of the valve train spring rate. And basically what that is you measure how far you have to compress the push rods, twist the rocker arms and twist the rocker arm tube and bend the arms, and all of these parts flexing, the rocker arm pivot shaft is bending, and find out how much motion there is on one end without there being any motion at all on the other, and you can quickly convert that into a number. And they started out at about 10,000 pounds per inch. That was the spring rate. And they were able to, when they started thinking along these lines, they were able to double that quite easily by making the push rods much heavier. They were aluminum thin wall things. They just made the wall a whole bunch thicker. And you would think, oh, well, you don't want to add weight because that's going to make a valves float. But the fact is that when you make the valve train extra rigid, it can handle spring rates that are a lot stiffer, because the real load in opening and closing the valves is inertia. And when you have a low spring rate, it means that the whole thing is compressing and expanding. And the push rods are bowstringing. They're doing this. That's why push rods are often made so they're thicker in the middle than at the ends, because it makes them stiffer against that lateral bending.
Well, and you
But
also want them in a straight run. Like when you cross them over on a big twin, if you rev a big twin, you can throw them out the side.
yeah,
And that was kind of what it was the trademark of the Sportster, was having the cams and having them have straight push rods up to the rockers.
yes, and that was something that dated back to 1929. That was I was sorry to see that go, because it was such a Harley icon. At any rate, when you have a springy valve train, that springing is going on the whole time. So it's like you're trying to measure for accurate carpentry with a ruler that is constantly going doing, 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 and something around 6 inches, I think. It adds uncertainty to where the valve is and how fast it's moving at any given moment. So if the valve train is expanding just before the valve is seating, you can imagine that the valve may bounce horribly. I was told by a Spintron operator, oh, NASCAR used to allow 5 bounces after closure, but then they cut it way back to 3. And of course, they're working with push rods and rockers. And the most rugged army tank looking parts are to be found in pro stock automobile. The rocker arms are just wonderful looking, tremendously. They're wonderful. I wish I had one now.
Yeah, it's great. They're just these massive. I mean,
And they're able, in those cases, to wreck the springs in one drag strip run. But of course, in dirt track, you've got to have an engine that stays together, so the valve springs are not stressed to that level, but they still have to be of remarkable quality. And that was another long evolution throughout all those years of the XR. So we think in terms, it's tempting to think in terms of standard soup up stuff as a means of winning races. more compression, greater airflow into the intake port. But if the engine won't operate at the speed that's necessary to beat the competition, then you have to fix that. Is it the main bearings? Is it the rod bearings? Are the pistons cracking around the wrist pin boss? How about wrist pins breaking? They experienced wrist pins breaking. And what did they trace it to? They traced it to little machining marks on the inside of the wrist pin. And of course, while everyone else is making wrist pins out of tool steel and vacuum remelted this and that, one of their suppliers told Harley, we're going to make these out of low carbon, and we're going to nitrogen harden them on the outside and the inside. And cramming all those nitrogen atoms into the surface of the steel puts everything into compression.
He smashed his face. For you listening on Spotify, Kevin just smashed his face. It was awesome. Demonstrating compression.
Putting things into compression means you have to bend them a lot more to relieve the compression and go into the tension that can create cracking. And those low-tech but nicely finished and hardened inside and out wrist pins proved to be reliable. And this is the lovely thing about this kind of work and this kind of documentation, because it shows you that life is not on the drawing. The drawing is a tremendous abstraction from the actual human work that's involved in making the thing on the drawing finish the race. And when you take away the people who knew how to do that and you leave behind only the drawing, that's all you have is a sketch. Well, it was something like this.
Yeah.
This happens over and over again when manufacturers go to China. They think, well, it's all on the drawing. The Chinese make what's on the drawing and it doesn't work. Oh, well, we forgot to tell you, we'll send a guy over that understands it.
Institutional knowledge.
Institutional knowledge.
What's that story? Was it the BSA factory? They moved a factory and the crankshafts weren't coming. There was a chatter.
Oh, yeah.
And then they found the guy who was operating the machine.
It was Norton.
And they brought him in. Norton. Yeah, they brought him in and he looks at the machine. And he's like, "Boy, where's me stick?" And they're like, "What?" and he had a stick with like a rounded kind of worn edge in it. And when the crank went and shiny, and when the crank went in the machine, he pulled that stick against the shaft so that it wouldn't chatter.
Take up the bearing clearance, yeah.
It wouldn't chatter.
So they got in their terrible little English car and drove back to Bracebridge Street, and he kind of poked around and, oh, there it is there. And they took it back and he used the stick and demonstrated how he could produce, I think they were boring cases, how he could use it to produce an on-spec bearing counterbore. And this is what happens when the people in charge of the budget throw up their hands. Oh, this machine's been giving excellent service since 1917. There's no need to change it. Thank you. All right, we'll manage. So I think all that wonderful glory, all those closely fought races, bikes sideways, closely packed through turns. The motorcycle had to be made into something that hardly came to the rider's attention. You didn't want the motorcycle diverting the rider's attention from the people on both sides and before and behind, because his job was to engage the enemy more closely. And the motorcycle should take care of itself. And they managed to do that far more often than not. And I think that it was quite an odyssey of constantly rising mechanical competency.
mechanical competency, and then the people who are running it, like Bill Werner and all the tuners who had so much knowledge. Somebody like Chris Carr, talking to Chris Carr at Santa Rosa, walking around the track and seeing they were doing some demonstration laps on the FTR, and Chris was talking to us about the track and all the different aspects of flat track racing. And we were talking about the XR still racing. I'm like, Brad's just like, how does he ride that cushion? And he's like, well, he's got a tremendous large pair of et ceteras. And I'm like,
Yeah.
oh, of course. Well, that's part of it, but he doesn't do it unknowingly. He's not just twisting it because he's brave. He maybe is brave, but he's also incredibly talented.
Yeah.
But he was talking about the gearing, the number of gears that you had available. You just had all of these gears, and he was saying, like, sometimes I would gear my bike knowing that I'm going to be in striking distance or putting myself in striking distance on the last lap, and I don't want to get drafted to the line. I'm going to draft them to the line, and I'm going to gear my bike for that specific point in the race to win from rolling on, to get across the line and not have to shift or whatever, and to maybe take that RPM to 10 something, not just 98 or whatever. I'm going to have that little extra to get them and to be right where it needed to be. And that kind of experience with a product, with an XR-750, and knowing all those details and having it expressed in a race win, that I did it because I did 0.08 difference in the gearing.
Yeah.
To me, that's just amazing.
But of course, these people are doing it every weekend, and they see patterns, and they think, oh, why don't I try this? It works. Then it becomes part of that rider's bag of tricks. Nixon used to do that. Nixon used to put on a lower first where getting off the last corner he would kill them there. And you have to have different ratios for every gear in the transmission, of course. And any factory does that. In the case of MotoGP, the 2027 rules will allow 4 different alternate primary ratios. Now, the reason people would change primary ratio is because once you had the anti-squat worked out for the back of your bike so that when you gas it, the bike did not squat down and push the front or suddenly top and stop and unload the tire with a click, but instead was in the working range. When you had it working like that, if you had to change the gearing, you'd be changing the angle of the top run of the chain to the central plane of the swing arm. And by changing the primary ratio, you could compensate. Leave the rear alone where the angle is the way you want it, and change the gearing with the primary ratio. And it just people being driven crazy, thinking about this stuff while they're trying to sleep, and suddenly sitting up, aha, big light bulb moment. And racing success is a big old hefty trash bag filled with those big light bulb moments that people have remembered because they're so important in a very little place.
Yep. I just gotta. Who knows why? Just gotta. I don't know. Yeah, the chain pull thing is really interesting because that leverage, the distance of the chain from the axle and from the swing arm pivot, how much is it pulling? And you want just enough. You don't want it to squat. No. But you also don't want it to top out, as you say, and you want just enough chain pull to have the bike be able to finish the corner in a nice way.
Yeah.
And that's what you're after. And then I think about changing the primary ratio, and then you're going to spin the clutch at a different speed. And how much effect does that have on what we're doing? I guess they're not really using clutches so at all, basically, but it would change the effect of the way the clutch operates, the way that
that was when slipper clutches were all there was. And the slipper clutch was originally invented at Honda, among other places, for the NR500. The slipper clutch really needs a different setting for every ratio in the gearbox. And it was Colin Edwards that made this clear to me, because I'm wandering around in a daze in the pit area at Motegi in 2003, and he came up to me and he said, "Come with me. Let's find some place where we can talk. I've got some cool stuff you'd like to hear about."
He was always great to talk to. He really was.
And we went and sat on the pit wall, and he told me when he was riding the Aprilia Cube, which was designed, the engine was designed by Cosworth, that they say, "Okay, we've got these turns down as far as the slipper is concerned. Now we've got to make a little change because it made it worse in turn 3." So he said they take out an 8,000 shim and put in a 5,000, and everything would be different. A whole new set of problems had come about because of 3,000ths of an inch in shim stack height. So no wonder they had to come up with engine braking control.
Yeah.
And I heard it working at Motegi. I'm thinking to myself, these engines are developing power all the way to the apex. What's going on here? And I went to see Kenny, and Kenny said, "Come in my garage here." And he showed me how the computer was given instructions, which came in through the laptop, that said in XYZ corner, in whichever situation, you will cancel this much of engine braking by opening the throttle this many degrees. So basically, they were just using a little fuel to cancel engine braking, and they could tailor it not only to each ratio, but to any corner or other situation on the racetrack.
So here's the barn job version of that. Is I was at a racetrack with Roland Sands, and I was riding like a Super Sport 600, and I was going into corners, and I'm like, man, the engine braking, it's too much going into this turn. You know, I just can't. It's too much. The bike's unstable at the back, and he's like, dude, turn up the idle.
Yeah.
I was like, mind blown.
That's what those first those superbike pioneers on those big 1,000cc bikes they had double the power of the previous generation of motorcycles. It was like a Bonneville with two engines, and in a Bonneville frame with Bonneville brakes and tires. And yes, there were problems, but in overcoming them, the second generation of sport bikes, which began with Honda Interceptor in 1983, was a direct result of the problems encountered between 1975 and 1982 with those big 1,000cc sit-ups. They had to fix so many things. Why don't we make them already fixed at the factory? And that's called a better motorcycle. And yes, racing does improve the breed because it makes people focus on what's good and what's working against you. What part of this motorcycle is my enemy? Let's defeat it. Let's give it candy bars. It's something to divert its attention away from screwing up our lap times.
Yeah, and the challenge there is the communication from the racing department to production.
Yeah.
And that's, I think, one reason a company like Honda stirs it around all the time. And you get Enrique, who worked in racing, Grand Prix racing, and he becomes the large project leader for the CBR 600 F4i.
Yeah.
And you get that guy with that expertise and that global view. And they always did that. They moved guys around. You know, it was like 2 years over here and 2 years over here.
Happened at Harley.
Yeah.
With the XR.
Yeah.
Because when they started with that 1970 Iron XR, it had a 5-piece crankshaft, 2 main shafts, fitted into the flywheels with a taper and a key and held by a nut. The crank pin, tapers, and nuts, and the rods.
I wanted to, that was on my list of I've got to ask Kevin, like, I can't believe they were doing this with a built up crankshaft. But if you have rollers and you have the rods that way,
How are you going to get them on there?
you
Yeah.
got to press it together. That's why it should be plain bearing. Like, let's get them back and, let's rededicate ourselves to
Yes.
grassroots racing in America.
So the first thing they did, of course, those shafts worked loose, and then they welded them. But they're only welded on one end, so there's all this wallowing and trouble.
Red fretting, I'm sure of it.
Yes, and so then they decided, what about forging the main shafts in one piece with the flywheels? No, we'd have to make a die. Oh dear, and all this sort of thing. But they did it, and it worked, and it was transferred to the big twin production engine later because it needed the same guarantee of staying together and staying off of warranty reports. So that was one big case in which it went straight from the race team to production, and there were numerous other examples of that because there was so much overlap between the race team. The race team was constantly talking to the metallurgy guy. The metallurgy guy was there to serve production. So there were specialists in different areas who were called in to consult with the race team. There was continuous diffusion of ideas among this whole population. The ideas were the free electrons, the delocalized electrons in the Harley organization.
He's referring to the metals podcast that we did last week. So, or the week before, but the metals podcast, we were talking about this. So it's a good throw. Go listen to that one if you haven't.
I think that they probably didn't have much friction in the sense of corporate department separation in those days. At one time, the racing department had like nearly 20 people in it, and they had a shop foreman. They had a dedicated machinist, and almost all of the mechanics on the factory team were competent at machine work. They could do welding, they could do fabricating. These were not Joes pulling parts and assembling stuff out of stock parts. They were the people who were remembering, oh yeah, I take the little rubber abrasive wheel and knock this sharp edge down because we've had a couple pop there and we don't want that.
And I'm happy to say that this is happening now at Honda, Kawasaki, all the places that have in-house departments. So if you go to Kawasaki, they have a fab shop. They have multiple mills, welders. They got parts everywhere. This is related to motocross. It's happening. KTM, Roger DeCoster is a superhuman example of this in expression, because at KTM Racing, there's Roger's mill. He has his own mill and he uses it to make parts. He actually is still using the mill. Like, he's not just running the team, running the effort, let's say. He's in there getting dirty and doing it. And they've got CNC porting machines. KTM's race effort out there is at their new headquarters. They built Pure Mobility and all that, many millions of dollars. And it's a beautiful complex, and it's great. And they're out there making chips, and there's a porting and department and people building heads. It's a thing of beauty. And it's beautiful to see Harley had in-house racing, foremen, machinists, people competent with the parts. Then they sort of offshored it, so to speak, to Vance and Hines. A lot of it was just happening outside the building. And now with baggers, it's all those people inside the building just going. And now ring packs. The ring pack that they use in the race motor is the ring pack they put in the 135 crate motor that they sell. The intake, they found a design for an intake manifold that they machined from billet and shipped it to like Road Atlanta or wherever the hell the race was, and it made more power. They sent that and said, "You're using this now on the production."
Yeah,
like here's it's great.
Yeah,
it's great
because although the great majority of people who ride motorcycles ride them in a, I hesitate to say a pedestrian manner, but they ride them well within their design capabilities because they are not professional riders and because they're on the street where there are no medics and where there are people on their phone who have no clue that you exist. But we want these motorcycles to be capable of doing everything that has been designed into them. So just having a bunch of parts that you put together and hope for the best, this is this is where all of those wonderful quality assurance systems that Dr. Deming and others developed during the war, and which Harley-Davidson became so adept at employing that they consulted with other American manufacturers on just-in-time and various quality assurance schemes. His motto, Dr. Deming's motto, was an increase in quality is an increase in production. Because if you're rejecting 30% for defects and you fix those defects, production is up 30%. And so continuous improvement as a manufacturing principle is the way a race team has to live all the time.
Right, it's crisis mode all the time. That's what's good about it. Is it's not we're not going to have a bunch of meetings. We're going to cut this and re-weld it and see what happens, or whatever that is. I want to talk about what you were saying about the street riders ride well within, the safety margins of the product or whatever. On the flip side of that, talking to someone at Hinckley Triumph during Hinckley Triumph's early days in development, and like, we've tested these bikes and we cut them loose into the American market. And the guy who was running Triumph in America at that time, he said, I told them we really got to test these things. We really, really got to test these things. And they said they did. And then he said they could not believe what riders in the market could break. Like, how'd they do that? And it's just, that's what's miraculous about, and they're all fit. Like, the Triumphs are amazing. And, I'm amazed at how great and reliable new motorcycles are. Like, just pick an R1M, go buy a Yamaha R1M, do the break-in, change your oil, get all that stuff done, and then turn the key on, start it, and let it idle. And just let it idle as long as you want, like a week. Keep putting gas in it. Ride it to Chuckwalla, ride it to Willow Springs, ride it to Laguna Seca, and then just cut endless laps on the motorcycle until the tires are smoked, and you got to change the tires. Tires. Keep lubing the chain. Change the chain. Keep cutting laps. And I would love to just do that. Like, every morning, get up and ride laps at Laguna Seca all day. And how long until I get a failure? I bet practically never. I would break before the bike.
Well, I talked with a Kawasaki DM years ago who said, well, riders like to do burnouts. It's sort of the fashion. And he said, so we've made the clutches bigger, and it made the failures more frequent. How did that work? Well, he said, they quickly found out they could do more burnouts with the stronger clutch. And so they did more and more. So we've made the clutch bigger again, and we're crossing our fingers on this one. But yes, the street rider is in relation to the motorcycle like the enlisted man to the various technologies that are available to the armed services, which is why they try to simplify things down to the point where, for those who can read, it says, this end toward enemy. And my middle son was in Afghanistan, and they told him, no, you can't work on those mine rollers. They can only be worked on by factory personnel. Well, on the books, we have 6 mine rollers, but there are no mine rollers available. So his officer said, fix this for me, will you? So he went and got a tractor and saw that one of the rollers could be nudged into the 90-degree position, and it would click in. The hydraulics were shot on it. So he was in the middle of doing that, and some busybody came up and said, I'm putting you on report. Fortunately, his officer arrived and said, he's doing exactly what I ordered him to do.
Yeah, we have a joke in the fire department about trying to make things firefighter proof. It's the same.
Yeah.
You know, we just, boy, you can break stuff. Any fleet vehicle, God. Anyway, different story. Couple things. Let's see. We talked about the crankshaft and having a built-up crankshaft. They and welding and all that. That was cool. There's the cam gear situation.
Oh yeah, each valve has its own tappet and its own cam lobe. So there are 4 cams, each with a gear, and that's why on a Sportster or an XR, you will see 2 parallel push rods, 2 parallel push rods. And down at the bottom, there are the gears. They're all meshed together. And the exhaust cam on an XR on the rear cylinder fails more often. And it used to be that all of these gears were made with standard clearance, tight and loose. And people would put them together to minimize the amount of clicking, because when you're lifting a valve that's 280 pounds open and it passes over the nose, suddenly you were trying to compress the spring with the torque in the cam, and now the spring is suddenly taken up all the clearance in the other direction. Click! And that's happening every revolution.
Yeah.
Of the camshaft. That's a lot of fatigue events, and those gears would break. But we have still competent gear making companies in this country. That could be solved. This same problem began to plague Manx Norton 500s in the early 50s, late 40s. Crank pins would break. Well, Nortons don't break crank pins. Now they do, because they had been a 6,500 RPM engine. Now they were turning 7,200. So what the clever boys were doing was using a Jaguar plain bearing connecting rod, making their own gigantic crank pin. And the last time that a Manx Norton won the Isle of Man Senior TT was 1961, when Mike Hillwood rode was it a Lacey? It was a highly modified Manx, and he was able to win because the MV that had been leading most of the race encountered sticking throttle. So they went to plain bearings on Manx Norton.
It's an interesting thing that you say about the development of the Manx Norton. You know, in vintage racing now, you're dealing with Manx Nortons that are basically made from completely new parts.
Yeah.
And everything's improved, and an actual Manx Norton, like a friend of mine, his dad, Tony Murphy, his father-in-law, is selling his very late Manx, and it's all original. And I'm like thinking to myself, man, I'd love to go vintage race a Manx, you know, in the 500 Premier class in armor or whatever. but it actually wouldn't be competitive
Sure.
because all the new bikes have been developed. And
And
so
they're turning 9,000.
right. And you take that thing out and like, oh, you're doing parade laps. You're not competitive.
Yep.
Back to the XR. I think one of the most beautiful things about the XR is the intake and combustion chamber.
Oh, no question. Yeah.
What do you think? Tell me about that.
Well, there are people who will tell you the Manx or the XR combustion chamber is a dead copy of a 350 BSA Gold Star. So I asked Pete Zylstra, and he said, no, certainly not. And then he told me some of the history of how they developed it, which included persuading Dick O'Brien to give up on oiled mahogany as the material to make airflow models and making it out of plexiglass. Oh, it'll be so expensive. Somebody will come down from accounting to talk to us. So I think it's in the museum. I think you can go see this thing. And it has the port that they ended up with. And I believe that during the development of the 1971, the modified iron motor, the one that Calvin Rayborn impressed the world with at the transatlantic match races that year, beat all these people who lived on those circuits with an engine made out of cast iron. Just can't happen. But
Team
it
America,
did.
buddy. Cast
Yeah,
iron. We love it.
It did happen. And I think that Dick O'Brien had made a big leap of understanding because he understood, and I think that Jerry Branch was probably part of the discussion and an important one because Jerry was working with cylinder heads from every other motorcycle that existed at that time. So he had lots of ideas in his head, and he
Highly
could see
energetic and a
yes,
genius, and
yep,
a genius with a lot of actual information.
yep. And he managed to persuade Obi to accept the idea that a properly designed low resistance intake port and a smaller valve would provide such high velocity in the mid-range that the mid-range would become much stronger by this simple mechanism. High-speed airflow in the port can keep on charging into the cylinder after the piston reaches bottom dead center, and even as it starts to come up to compress the fresh charge, because there's a lot of momentum. Now, people talk about mean intake velocity, and that means averaged over the whole time that the valve is open. And they have figures like 343 feet per second. But the fact is, the first half of the stroke, the air is kind of going, do you feel something happening? I think we have to go this way. The inertia of the air resists being accelerated. And by the second half of the stroke, the air is catching up. And by bottom center, it's going really fast. And I mean up close to the speed of sound. So it's no joke that it can keep on crowding in there. And this is why, when I asked Claudio Domenicali, who is now the big cheese at Ducati, what about keeping the intake valves open longer after bottom center? He said, yes, you can make all kinds of power that way, but it makes the power band impossible to use. Well, there's a statement. And so the XR could be said to be a racing tractor because they paid attention to every part of the power band that was actually used on the racetrack and made it better, as much better as they possibly could. And there were some steps along the way. I think the late Kenny Augustine was called in to rework the exhaust port, at least. He came up with the flat floor, which you can trace back to Jocko Johnson in the late 50s. But these people who work with airflow they're all working with the same air. So don't be surprised if they come up with similar solutions.
And they're all go ahead.
Well, raising the floor of the port and then raising the roof of the port takes some of the angle out. And as Kenny liked to say, you can make air go fast and you can make air go around corners, but you can't do both at the same time. So this is why exhaust ports pointing up have appeared on engines like Ducati's Testastretta. Usually, however, packaging, the exhaust pipes have to come out of the cylinder head and tuck down immediately to allow room for the radiator and the front tire. So compromise, it's necessary.
You said everyone's working with the same air, so it's no surprise that they come up with the similar solutions. Everyone's working with the same dirt.
Yeah.
Right. And that's why the FTR 750 torque curve is this incredible, like flat, manageable thing.
Yes.
That's the only way you get off a corner.
And in fact, the mile track lap record hasn't changed all that much since 1911. I think dirt is a constant. They haven't found ways to fill it with some kind of glue like they see the drag strip, the launch areas.
Yeah, right. VHT, a highly variable constant. The moisture and different tracks and gravel and all the things. But yeah, you only get so much, and you only have so much to work with. And that's true in MotoGP. You only have so much traction to work with. It's just you have a lot more, but you still need a manageable power band. You're still trying to have the power and control to make the most of the traction for as long as you have it.
And you talk to experienced dirt track builders, and they'll say somewhere between 90 and 100 horsepower with a good power band is what you need. There have been lots of much more powerful engines put into dirt trackers, engines making up to 125 horsepower, and the rider just comes in shaking his head and says, well, I'd like to hook this thing up, but I can't figure out how.
Yeah, Super Trackers was a real interesting experiment around 99, 2000 in that era. And they were running, Ducati V-twins and TL1000 motors and just the various manufacturers, Honda and all that, having V-twins, 90-degree V-twins and Desmo V-twins. And
well, they're hoping to go to an entirely production-based formula for American flat track. And the argument is that having one factory race engine versus everybody's home built, even if it's a very high level home built, like Bill Werner's Kawasaki's and what's been done with them since, where it's a Kawasaki in name only. People would like to imagine having several brands that all finish very close in every race. But the fearful thing, the dangerous outcome, is what I call the Kalex effect. When they came out with Moto 2, which is the next class to MotoGP, where people arrive, they win Moto 2, and they're sort of, and now, they decided Moto 2 will have stock engines, so that will save everyone the expense of developing horsepower, and it will unleash a torrent of chassis innovation. And what it unleashed was Kalex. Kalex made a chassis that everyone liked, and nobody uses anything else.
And Triumph does the engine, and that's what you get.
And this is
I rock.
always a danger in racing, is that something will turn out to be, okay, you need one of these. And it won't matter. People have called Yamaha, people have called Kawasaki and said, "Oh, please, you're coming to help us in dirt track, aren't you? It's American grassroots sport. It'll help you sell motorcycles." And they're saying, nobody goes to these things anymore. And, they don't buy new motorcycles. Don't answer the phone next time. Put it on the reject list. And it goes like that.
Well, and if you're in racing, if you're in the racing department at any manufacturer, Yamaha's a good example because they've had highly enthusiastic people in the racing department and great technicians. Yep. But the other pressure there is budgetary.
Yeah.
And you see it there isn't a huge factory Yamaha rig, and we're not getting engines shipped over from Japan that I'm aware of. It's a factory supported team. They're there, but they got a lot going on in Supercross and motocross. And when they debuted the T7, the 700cc motor and a flat track frame, we went to them. We had a rider, Hayden Gillum. We were like, hey, let's race a flat track bike and do a media series and get Hayden Gillum. And when we talked to the folks at Yamaha, I'm like, we love that idea, but we don't have the money to do it. Yeah. We have to focus on these areas in racing. And they were spending a lot of racing. Suzuki was spending a lot on racing, and then they kind of hit the reset button, and they have good racing programs that they're probably spending quite a bit less on. So that's part of the challenge, of course.
Yes, but what never ends is people with ideas. And
the desire to race whatever.
Yeah.
That's the beauty of it.
When the factories have money to spend, those people with ideas often find employment. And at other times, they get home late and they find all the lights in their house are dark, and they're thinking, damn, I thought I was getting home earlier than this.
Yeah.
Because they're at the shop.
Yeah.
Trying to solve a problem.
This is a good place to say thanks for listening, folks. But I want to tuck one thing in I think it was the Metals podcast. You said, "Oh, I put a set of pistons in my ex-wife's oven."
Yes.
And somebody pulled that up and just, ex-wife's oven.
Yes. Sure.
It was good stuff. We appreciate your comments. We're super glad you're listening with us. Keep on listening, keep on going in the comments, because we are so delighted that you're riding along with us in this. And
we want to hear from you.
We want to hear from you. A lot of the topics that we have talked about, the oval piston Honda, that's a previous podcast. It's all come out of the comments. We're reading them. I try to get in there and say, hey, howdy, and we appreciate it. And thanks for listening. We'll see you next week.